Okay, so this first problem is just like the first problem that we did in class, where you have two vehicles driving in opposite directions. I drew a chart just so that it would be a little easier to document your information. One car leaves Chicago headed for Cleveland, a distance of 343 miles. At the same time, a second car leaves Cleveland headed toward Chicago. If the first car averages 50 miles per hour and the second car averages 48 miles per hour, how long will it take the cars to meet? So the first thing we have to decide is what information do they give us about car 1 and what information do we have about car 2? Remember, rate times time equals distance. So for car number 1, it says that it averages 50 miles per hour. So that would be our rate. Car number 2 averages 48 miles per hour. So that would be the rate for that one. What we don't know is the time, and I'm going to make car 1 my X. And since they have driven the same amount of time, they left Chicago at the same time, we will use the same variable for each. So both of them will have an X for time. So our distance for each of them, rate times time, we would just take 50x for distance for car 1, 48x for car 2. And like we learned in class, when you have two cars going in opposite directions, we're going to add them together. So car number 1 plus car number 2 have to equal the total distance, which in the problem they told us the total distance is 343. So that's the problem that we're trying to solve. So when we combine like terms on the left, we get 98x equals 343. Divide both sides by 98. And x is equal to 3.5, which tells us that it would take them 3 hours and 30 minutes before they will meet. For problem number 2, this is an example of problem number 2, where we have two vehicles going in the same direction, trying to figure out when they will meet. So in this situation, a cyclist leaves Las Vegas riding at a rate of 18 miles per hour, and 1 hour later, a car leaves Vegas going 45 miles per hour in the same direction. How long will it take the car to overtake the cyclist? Remember, we talked about how two cars going in the same direction looks like an equal sign. That's our hint that we set the distances equal to one another. So let's look back at the problem and figure out what information we've been given. So again, rate times time equals distance. So the cyclist is going at a rate of 18 miles per hour. And we're going to say that his time is X. The car is going 45 miles per hour in the same direction. Now we have to be careful with the time on this one because remember, they told us that the car left 1 hour later. So the question that we always have to ask ourselves is, how would that be different from the time that the cyclist is riding? So if we think about it, using an example for time. So let's say that the cyclist was driving for 5 hours, for example. And remember, this is just an example to kind of wrap our minds around how long each of them were driving and how they relate. If the cyclist was driving for 5 hours and the car left 1 hour later, That means that they would have been driving 4 hours. So we can use this information simply to decide how do we relate the X for time for the cyclist to the time for the car. Well, if we look here, it's 1 hour less. So our time is going to be X minus 1, or the time the cyclist was riding minus 1. So when we put those two together, the cyclist distance is going to be 18x, and the car's distance is going to be 45 times, make sure you use your parentheses, x minus 1. So now let's set these two equal to each other. We're going to take the cyclist and we're going to set it equal to the car. And then we're going to simplify both sides. So we distribute the 45. We're going to subtract 45x from both sides. Negative 45 on the right is equal to negative 27x on the left. Divide both sides by negative 27. And x is equal to 1.6 repeating. Now remember, we talked about in class today, you cannot leave this as 1.6 repeating because the question is asking how long will it take for the car to overtake the cyclist. We then need to take this 1.6 and change it from a decimal into actual time. So 1.6 as a decimal is 1 2/3. So what we need to do is take that 2/3 of an hour, and if we think about a 60-minute hour, cut in thirds, we get 20 minutes. So our answer, 1 2/3, in time would be 1 hour and 40 minutes. Now our equation has given us the answer of 1 hour and 40 minutes for x. So this tells us that x being the variable that represents the time the cyclist was driving, we also need to figure out how long the car was driving, because actually the answer asks how long will it take the car to overtake the cyclist. So we figured out the cyclist would be driving for 1 hour and 40 minutes. But if we look at the variable for the car was driving for 1 hour less than the cyclist. So if the cyclist was driving for 1 hour and 40 minutes, the car was driving for 40 minutes. So it would take the car 40 minutes to overtake the cyclist. So even though in our answer, when we solved our equation, we got 1 hour and 40 minutes, it's really important that you take that information and analyze it based on your problem. What are they asking you to solve for? And how do you get that information based on the variables that you chose?